We also have a lot of wide variety of built-ins, functional built-ins that help you uh, run pretty complex queries without you writing SQL queries by hand. Let's say JSON ag is about finding the aggregation of the items, and then array push, you can modify, massage your arrays on the JSON. Yeah, so extract. So all these are possible even by writing the queries by hand, like I have shown in the example. But all these built-ins, native built-ins, make the developer time, reduce the developer time, and make developers really productive. Yeah, so the JSON with its unique storage format is already quite optimized, and most of the queries run pretty fast without any manual tuning or yeah, indexing strategies. But for certain highly selective queries where you want to focus on certain rows that match criteria, we have indexing available on the JSON column, so that you would be able to create indexes on the fields that you're interested in for your queries. And the first style of indexing is the general column index that is possible on the scalar columns or the normal columns. So you would be able to promote a field into a column and create a normal hash index on top of it. And along with that, we also newly introduced in the recent 9.0 release for SingleStore some powerful indexing strategy called multi-value index. So the one of the a limitation or drawback with the persisted uh, column index is so the JSON data uh, it's pretty flexible. So if you follow the path of the JSON, the path can lead to a single field, or the endpoint of the path can be a whole object itself, or it can be an array that store many values. So the the columnar hash index on the persisted data doesn't really support arrays, because each array has in itself a lot of elements to be indexed. So that's the advantage that you get on multi-value index. So for the multi-value index, even though the JSON path you are interested in has an array, all the elements in the array get indexed, and you would be able to do uh, quite efficient searching and finding on array elements level as well. And we also have full text index, which is powered by Lucene. So you would be able to do all the match queries using tokenizers and different language, yeah, lexicographic tokenizers you can build on it, and do fuzzy search, do key value mapping, and also use different powerful expressions that Java Lucene offers. So we'll look more in detail on the multi-value index, on how you can create it and what are the use cases that it powers. So Slava will be taking it over. Yeah.
Yeah, thank you, Spandana. Do you mind to continue presenting?
Sure.
Awesome. Yep. So yeah, we're introducing the new type of index called multi-value hash index. As you may see on the right side on the slide, we have an example of the JSON object. So it can be the output of your API or other systems. And here's the example about the reviews for the books. And imagine that you wanted uh, to perform fast lookups to know all the books that have rating of 5, or all the reviews of some particular person. And this new type of index allows you doing that. So in order to do that, we are using our powerful built-in function called JSON match any. So basically it returns a boolean based on the specific key pass to your object and by the predicate. Predicate can be any type of Boolean expression. It can be equality operator. It can be in list. it can be even more advanced expressions. And in this example, for example, if you take a look at the reviews, and we would like to select all data that have the rating of 3 or 4, for instance. You might take a look that we have the reviewer Eve with rating 4 and reviewer Bob with rating 3 as well. So in order to do that, we need to call JSON match any function, and we need to provide the path to it. So it's basically reviews column, key reviews, and sub key of rating. And the expression will be we have the placeholder called match param JSON. Basically, it dynamically replaces with the JSON that we are currently traversing. So in case of reviews and rating, it will be just the integer 3, 4, 5 in this example. And we are evaluating this placeholder value over our target. So in this case, it's 3 or 4. And we may depending on the input, we may return or not the exact values. So another example is reviewer name. So we are looking for all the reviews made by Eve. So you may take a look on the below example. So it's the same, but we changed the key path to it. So from reviews rating to reviews reviewer, and the match param. Sorry, Spandana, can you go back to slides, please? Yeah, thanks. Yeah, and matching JSON equals to the string if. And on the right side, we also have the example of performing similar operations, but over our SingleStore Kai queries. So there it's much iconic and smaller. Yeah, next slide, please. Yeah, so under the hood, basically we are using our already existed column store secondary hash index. So in order to explain how it works under the hood, I use the same example, but I highlighted the values of reviewer. So imagine we would like to index our reviewer name. So we would like to perform fast lookups based on the reviewer name and get the all the related corresponding row IDs immediately. So in order to do that, we need to provide the key path to the index that we were looking for. So for our case, it can be reviews and sub-key reviewer. So how it works under the hood. We are looking at all values under this particular key path. In our case, it's only 4 strings, Alice, Eve, twice, and Bob. Per each string, we are calculating hash function. So basically, it takes the string as input and it returns integer as output, because operating over integers is faster and it's a way to, and it's smaller for storage purposes. And basically, per each hash value, we also add in the list of corresponding table row IDs. So for the Alice, we see that we have the only occurrences for the first ID object of the JSON. For the Eve, it occurred twice, for the first one and the second one. And for the Bob, it occurred only for the third JSON object. So once we build that index, if we want to perform matching, we need to how it works. So basically, you're providing the Boolean expression using our already mentioned JSON match any function. You're providing the predicate. In our case, that JSON string should be equal to the Eve, and we will perform the hash function over Eve string, and it will give us corresponding table row IDs, which for our case is the first and second one objects. And so this case will give us the exact corresponding row IDs, and we simply materialize the rows under that particular row IDs. Next slide, please. Yeah, so the syntax for it, so you may either create the syntax immediately when you're creating the table, or if you already have the table with the data, you can simply alter it, adding your index. So the syntax for it is called multi-value index, where you, in brackets, you're specifying the JSON or BSON columns that you would like to be indexed. And then you have index options. Index options is also a JSON object, which tells the indexer how to index or tokenize the data. So it has exactly two arguments, tokenizer. For now, it's only much any corresponding to the JSON much any function. And the path, it can be the empty array, meaning that we would like to index the top level JSON array, or it can be passed to some sub values or sub documents. So the example below is that we would like to access addresses and then the city. And the index is quite smart to understand if it's the object, then we would access sub-object of that. But if we have an array of objects, we also would access all elements of that array. Next slide, please. Yeah, it was, we were inspired when developing that by famous open source Postgres GIN index, known as generalized inverted index. So it's, you may find the similar things, and it allows either migration from the Postgres to SingleStore. It currently works on both JSON and BSON data types, and we index only specific key paths. So if you would like to perform fast lookups based on two keys, like you would like to fast lookup at the same time for the reviewer name and for the rating, you would need to create two separate indexes. Next slide, please. Yep, and in order to understand that your index was actually invoked or applied, you can use explain command by adding the explain word before your select query. And if you would see near the column store filter that you have the phrase multi-value hash index, it means that our hash index was involved, and it gives you the fast lookup for your predicate. Yeah, that's all from me. Thanks.
Yeah, so we'll quickly look into a demo on how multi-value index makes a difference in the query latency for huge volumes of data for the highly selective queries. So this is my single store portal, the cloud portal. Once you log into singlestore.com and create your account, you get 600 free credits that you can use to create a sample workspace and directly get to running your queries. So for this, I already have created a database called multi-value here and preloaded certain tables. So just to show how the tables are. So this particular data is from the TPCH. We have two tables called orders and product IDs as part of TPCH. And this is a transformed version where the orders as well as the product IDs that belong to an order are kind of joined into a single table in the denormalized fashion. That's generally pretty common in the NoSQL document databases. So here you can see that the order ID when it was created and all the products that are part of this particular order. And what I'm generally interested in here is I have a particular product ID in mind, and I want to really see in how many orders was it part of, which product ID is pretty popular, which product is actually selling quite fast. And those kind of queries are, if you have certain product that you really want to understand the analytics, sales analytics on top of it, you would want to search for the orders where there is a particular product in its cart or in the order list. So in this case, I have picked an product ID of 20765, and let me uh, run this query to find out all the orders where that contain this particular product ID. And this is the syntax where you have the table and you are giving the path. So in this case, this array is directly on the top level. So I'm directly giving the column name here. Let's say if this array is deeply nested inside, you can specify the path to that key. So in this case, it's on the top level. So I just directly give the product ID's column name, and I'm matching for this particular number. Uh, and let me quickly run it to show you how fast it is. And yeah, it runs in milliseconds. But now let me show you how many rows are there in it. It's almost 10 million rows, and it runs pretty fast. This is because I already created the multi-value index on top of the product IDs array. And I have taken the same table and created a copy and removed the index here. So this doesn't really have any index. And so this also has the same schema, just that it doesn't have the index. So you can even quickly check. So if I go here, orders table, this is the SQL schema for how the table is created. And you can see that the orders table has particular key created on the product IDs column, and the index options match any, and the path is top level. That's why it is empty. And the orders without index also has the same structure, but it doesn't have the multi-value index. Now let me run the same query on the other table, and yeah, it's going to give us some time. And I want to show just that this table also has the same count of rows. So without an index, what this query has to do is it would have to go through all the rows, go row by row, and go through each item in the array to see if this particular number is there, this particular product ID is there. So searches for that number in the row 1, row 2, row 3, and it goes till all the 10 million rows. And it returned back in 30 seconds. So that is the advantage that you get by indexing the values that are of interest to you, so that as the values are already indexed, it can directly point and reach the rows immediately. Yeah, so you can quickly see that the huge magnitude of performance gains that you got where the query returns in milliseconds versus something which doesn't have an index. Yeah, so both the tables are having the same count. And to show you how to see whether the index is used or not, you can directly go through the query profile. You can find the query profile using the explain before the query, which shows you, that what are the steps the query has taken to execute. And it is using this filter. It's using the hash index for executing the column store filter. If I do the same, it'll take a while. I really wanted to show the another way of looking at the profile. We have something called visual profile, where it shows in a graphical representation whatever you saw in the textual format. Yeah, here as well you can see that in the filter the hash index is getting used. Let me go back to my editor. Yeah, I'll just leave it to run, and we'll see if there are any further questions. Yeah, so yeah, as it's just an explain, it's not really running the query. So yeah, this one has the multi-value in it, and if the table doesn't really have any index, you would not be able to see that the filter is using any index, and that would take a lot of time. Yeah, so evaluate whether your workloads have certain JSON heavy queries, and the JSON is quite complex with nesting and arrays. So multi-value index is particularly something that can help uh, optimize your queries even further, and give you millisecond response times even on the most complex JSON objects that you may have. Yeah, all this with all the other capabilities of single store, like fast joins and the unique column store execution, within which you will be able to run pretty complex queries at high concurrency with millisecond query latency. Yeah, thank you. That's all from our side today. So we'll wait for a couple of minutes if there are any questions, and Yukti can take over to talk about what's in store for, yeah, in the future webinars.
All right. Thank you so much, Spandana. It was so cool. And like, is there a link that we have to the demo? Like, if you have a GitHub repository?
Sure, sure. We can definitely create one.
Yeah.
It's just that
Yeah.
the data set has to be loaded, but yeah, the queries are pretty simple.
Yeah, like it should, if like, like folks can like
Mm.
follow along. There's a lot of people like after the session, they join and like so basically some people are not able to join live. So like it's included in the follow-up email. So for everyone that has attended live, or if you were not there in the beginning of the session, we will be sending a recording of the session along with all the resources. I saw that Slava has shared a link to a documentation that's relevant to the webinar. So that will also be included. And yes, Panna, if there's anything else that you would like to share, so like let me know. And to everyone that's attending, we are officially open for questions now. So if there's any questions that you would like the speakers to address, because they both are experts on the topic, please feel free to send them in. And if you're not, if there's no questions right now, but if you have something later, you can always reply to the follow-up email that you will get. It will directly come to me and I'll forward it to the speakers, or like we'll take care of that. So yeah, you can utilize the Q&A button which is present at the bottom of your console for any questions. So yeah, Spandana, like there was one question that that has been taken care of via text, but like do you want to take it up live? So do
Mhm.
you want to, can you read the question, or like do you want me to read the question?
Yeah, I'm not able to find it. Yeah, go
It's okay,
ahead.
I can read it. So,
Yeah.
there's a question from Cole. They say that is there a document or example of applying full text indexes to JSON columns?
Yeah, so we have a detailed documentation on how to use the full text index and do pretty complex queries on top of full text index. So we can share the documentation link. Can I do it on the chat?
Yeah, he's already done that. Like, I
Okay.
was thinking
Yeah.
to add something. So, yeah, like then I think then we don't have any other questions. So, yeah, then I
I
think we
think we
can.
have a raised hand in the
Oh,
participants.
yeah, so yeah, like for anyone that's attending live and maybe you guys joined late. So one of our housekeeping rules is that we don't take up any questions like, by raising hand, because everyone's in a listen only mode. So that's not possible. So if there's anything, you can utilize the Q&A button. It's like in the middle of the console. So you can utilize that. I mean, and we can always take up questions via email as well. So yeah, I don't see any other questions coming in though. So yeah, Spanda, do you like, would you be okay in
Yeah.
wrapping up?
Yeah. So we are well in time. So yeah.
Yeah. Okay. So, Slava, you have something else to share?
Nope.
Okay. So, yeah, thanks everyone for joining. We have amazing webinars that are going to be coming up in the future, and I'll make sure to include them in our email. So, if you like today's session, we will be more than happy to have you in other, in all our other webinars that are coming up in the future. So, yeah, there's a comment from William. Thank you for the informative webinar. Thanks so much for our speakers to, in actually putting this together. It takes a lot of time and energy of their busy schedules. So yeah, we will be in front of you all with more informative free sessions. So yeah, stay tuned for my email and keep on checking our resources page. Okay, I don't have anything else, so I think we can conclude the webinar now. Okay.